Okay, find the value of c that creates a perfect square trinomial, then factor it. So we have x to the second plus 16x plus c. Your job is to, first off, you got to find your value for c. So c equals b divided by 2 to the second power. And then I use my t-table. Okay. Alright, remember the object is to be able to write a binomial to the second power. That's what you're supposed to be doing. So the b is 16. 16 divided by 2 then is 8, so c equals 8 to the second power. So c then equals 8 times 8, and then c would equal 64. So that's your c value, 64. Now you put that into factored form, so a, b, c. So I find the a times c product, 64. Positive, it has to be a match. So put two signs that match, and we have to add to positive 16. Okay, now rather than waste your time doing dividing, the thing is when you use the b, when you come up with your c using the b divided by 2 to the second power, you can just square root your 64. That's 8, so I put 8 on each side of the table, and if you add those, that's negative 16. We need it to be positive 16, so you're adding it, negative 16. To make it into positive 16, you make double positives. Now your a down here is a 1x to the second power. So if a is 1x to the second power, you put in your parentheses just like you would on a normal problem, plus 8, then xx, and then we apply the 1 in front, okay? But nothing happens to 1x and 8 because 1 and 8 are only divisible by 1. So again, it's x plus 8, x plus 8. Therefore, it's the same thing. So it's x plus 8 to the second power. Okay, rewrite the following quadratic equation in vertex form. So you put y equals, y equals, y equals. Okay, you're just taking, this is a standard form. It's ABC form. Don't label ABC yet. But you need to get it into vertex form where you have the binomial to the second power. Okay, so a couple things you want to do. You have to use the c equals b divided by 2 to the second power. You need to use your t-table. And some things you want to set up here. Okay. You want to put a parentheses with 1x to the second inside it. That's your first thing. Then you want to make two parentheses. Then you want to end up with a parentheses to the second. So you got to remember to set this up, and then this set up right here. Okay, so let's talk about this. The first thing I do is put a 1 in front of my x second, so I know that that's a 1. And then I parenthesize the x second and the x. We're going to kick the plus 15 out. Now, I need 1x second. Do I already have 1x second? I do, so I just put the minus 10x. And this is my a, this is my b. This is not going to be my c. I come up with my c, okay, with this formula here, b divided by 2 to the second power. So b is negative 10. Negative 10 divided by 5 is 2 is negative 5. And then negative 5 to the second is negative 5 times negative 5, and that's going to be 25. Okay, so that's your c value. Now the next step, and by the way, this 25 right here that you brought in, you want to circle it and check the front of your parentheses. If there's no number there, well, that's good. Then I can just add 25 to this side. Because see, if I'm adding 25 to, here's my equals. If I'm adding 25 to this side of the equation, I need to add 25 to this side of the equation so the equation stays balanced. So plus 25. So whatever your c value is, you're going to put that there and circle it, okay? And if there's not a number in front, then you also have to add that 25 over to the other side. Now, I don't really want this 25 added to y, so if I want to get rid of the plus 25, I'm going to minus 25, but instead of, I'm going to minus it then from the 15. Okay, now I fill in my two parentheses with the t-chart, the factoring. I'm putting this in, it's a trinomial, I need to factor it. So 1 times 25 is 25, positive. So the signs have to match. They have to add to the b, which is negative 10. So rather than divide, when you use this formula here to find your c, okay, you can just find the square root of 25, and that's going to be 5. So you put 5 on each end. That's a quick way to get it. Those add to negative 10 right now. Okay, so your a is 1x to the second power. So you put negative 5, x second is x times x, and then the 1 you can apply in front, but again, nothing happens. So you take the 1's off the front, and it's x minus 5 times x minus 5. Now also, 15 minus 25 is negative 10. You can either put minus 10 or plus negative 10. Doesn't matter. So then in this parentheses, it's x minus 5 to the second, because there's 2 of them, minus 10. Okay. Okay, next problem. Rewrite the following quadratic equation in vertex form. So y equals, y equals, y equals. Okay, you'll need to use your b divided by 2 to the second power. C equals, put that in front because that's what that's used to find, is a c value that makes a perfect square trinomial. And then my t table. So you write those two things. Now, you want to put a parentheses with 1x to the second. You want to do that, it always needs to be 1. And then 2 parentheses, then a parentheses to the second. You set that up, then you'll at least have some word of a direction. Now, we kick out the minus 26, okay? Now, do we have 1x to the second? No, we don't. We have 4x to the second. So again, you want to parenthesize this, okay? Parenthesize that, just like you did on the last problem. You have a 4x to the second. You parenthesize these two terms together. So if I have a 4x to the second, I need to get a 1x second. I need to divide by 4, but I also need to divide the negative 40 by 4. Now this 4, not 4x, okay, because we want it to stay x to the second. We don't want to put an x down there and have to make it 1x. Now this 4 I'm dividing by, you don't just get rid of, you bring that out here, okay. So again, whatever I'm dividing by comes out here. That's 1x to the second minus 10x, okay. Now, this is what we're finding. A is 1x second, B is negative 10x, C is what I need to find, and I use this simple short little formula here. So B is negative 10. Negative 10 divided by 2 is negative 5 to the second. So it would be negative 5 times negative 5, and then it would be positive 25. Okay? Negative times negative is a positive, 5 times 5 is 25. Now, after you bring in that C, you want to circle it, and if you have a number out here, you need to circle it because the number you're going to add to the other side is not 25. It's 25 times 4 now. See, the last problem, there was no number out there, so it was just the C I took out there. Now, I brought in 4 times 25. 25 times 4 is 100, so 100 is the value we are really adding to both sides. Okay. Then you quickly go and subtract the 100 from the negative 26 so that the y is now by itself. Okay. Okay, now here's your A, here's your B, here's your C. You're ready to factor it. Okay. You're still going to have the 4, and you're still going to have whatever this is outside, negative 26 minus 100. So 1 times 25 is 25. It's a positive. So it's a match. It's got to add to negative 10. If you square root 25, you'll find it. Okay. So the square root of the number 25 is 5 again. So it'll be 5 on each side, and that adds to negative 10. Okay. So negative 5, negative 5. A again is always 1x to the second, so it's going to be xx. You can apply the 1, but then you can't do anything, so then you end up taking the 1's off. So I put x minus 5, x minus 5. Don't forget to take your negative 26 minus 100, and that's negative 126. Okay, so you have 4x minus 5 to the second, and then minus 126. Alright, number 4, find the value for k. I don't like k, put b, and down there where there's a k, put a b. You need to find what b equals. Find the value of b that creates a perfect square trinomial. This doesn't need to be factored, you just need to find the b value. Okay, so I know the formula to find c, but I already have c. That's not the issue. I need to find b. So b is equal to the a times c product, the square root of the ac product, and then doubled times by 2. Okay, so the a is 1, the c is 100, so it'd be 1 times 100, that's 100. So we'd have the square root of 100 times 2. Square root of 100 is 10, and then times 2 is 20, so b is 20. Okay, evaluate I to the power of 10 now. You want to make I to the second. Remember, I to the second equals negative 1. So I write I to the second, and I don't stop writing I to the second until I have 10 of them. So that's I, that'd be 4, 6, 8, 10. So all these are replaced with negative 1 now. That's the value for I to the second. Okay, a bunch of 1's multiplied together is 1, and how many of them are there? 1, 2, 3, 4, 5. Well, that's an odd number, so the negative is going to stick to the answer. Okay, if it's an even, it's a positive. Okay, simplify. Negative 7 plus 17i plus negative 12 plus 5i. This is complex number 1, complex number 2. It's inside each quantity. When there's I involved, they're called complex numbers. We have a plus in between the two, so it's easy. We just combine the constants and the i's. So constants, negative 7 plus negative 12 is negative 19. And the i's, 17 plus 5 is 22. Easy. Okay, subtraction of complex numbers is the same thing. You need to make it positive, and then everything in the second quantity changes to opposite. So 25 is negative, 7 is positive. So blank plus blank I. So the constants, 18 plus negative 25 is negative 7. Negative 4 plus 7 is 3. Okay, number 4. Now we have two complex numbers. Okay, 3 plus 12i, 2 minus 7i. But now there's no sign in between, so that indicates multiplication. So to multiply, we need to start distributing. First, we start with the 3. 3 to 2, 3 to negative 7i. Okay, then 12i to 2 and 12i to negative 7i. So this equals 6. This equals negative 21i. This is 24i. And this is negative 84i to the second. Remember, I to the second has to be replaced with negative 1. And then we take negative 84 times negative 1, which is 84. So we have the constants and the i's. 6 plus 84 is 90. And negative 21 plus 24 is 3. 90 plus 3i. Okay, we will not be doing this problem on the bottom, but we are doing the problems on the top. Simplify. Now, it should say find the quotient. That's what it should say, because I end up dividing. But I can't divide if there's an I down there on the bottom. Okay, you need to write a new fraction where you don't have I, an equivalent fraction. Well, to get an equivalent fraction, we want to parenthesize the top and the bottom, and then there's another fraction that we need to multiply by. Whatever I put here, I put here. Okay, now what I put here depends on how many terms are on the bottom, because remember, the bottom is the problem. We have I on the bottom. We got to get that out of there. Well, there's only one term on the bottom. So if there's only one term, you can just put I and then copy that to the top. And now you're going to multiply the tops and the bottoms to get a new fraction, product. So top, I don't know why I'm doing that. Here, I shouldn't have drawn the chart. I should just say top, bottom. Okay, so the top, 3 times 1i. That's done. Then 2i times 1i. Okay, it's 3i. And then you're going to get 2i to the second power. I to the second power is replaced with -1, and 2 times -1 is -2. Okay, so the top now has -2 plus 3i. Now the bottom, you take 8i times 1i. That's 8i to the second. So I to the second changes to -1, and that's -8. Okay, now we're good to divide. Remember, you need to divide the -2 by -8 and the 3i by -8. So -2 divided by -8 is 0.25. You can put that, or you can put 1/4. I'm fine with the decimal or the fraction. Then 3 divided by -8, remember, you're still going to have the I. Whatever the quotient is will still be multiplied by I. Okay. Don't write that. If it's more than 2 decimals, second PRB it, okay? It's going to be -3/8, okay? So you can put -3/8 or plus -3/8. I don't care, but it's still multiplied by I. Okay, in our next problem, again, we need to create a quotient where there's no more I on the bottom. Okay, now you have 2 terms on the bottom. So 2 terms, you have to use the conjugate method. Just putting a 1i down there doesn't do anything. There will still be an I at that point. Go conjugate method. You keep the constant the same, but you switch the I term to the opposite, so it'll be -8i. Take that, copy it to the top. Okay, that's the conjugate method. Then you do the exact same thing, top, bottom. Okay, so on top we take 7 times 2, 7 times -8i. Then -3i times 2, then -3i times -8i. So it's 14, -56i, -6i, positive 24i to the second. So the I to the second is replaced with -1. 24 times -1 is -24. Okay, so I can combine the 14 to the -24, and that'd be -10. And then the i's, -56 plus -6 is -62i. So that's what you put on top. Okay, then in the denominator, 2 times 2, 2 times -8i, 8i times 2, then 8i times -8i. It's 4, -16i, positive 16i, and that's -64i to the second. So I to the second is replaced with -1. -64 times -1 is 64. Then you add the constants to get 68. And the i's, when you add those, -16 plus 16 is 0. So don't put anything. You just put 68 down here. Now you can go ahead and divide. So I'm dividing the -10 by the 68, okay? And I'm also going to be dividing the -62 by 68. Second PRB that. -5/34. Then -62 divided by 68. Second PRB. -31/34. Okay, you can put plus, negative, or minus. I don't really care, but that one's still multiplied by I. Okay, now you're solving the equations. Negative 2x to the second power plus 14 equals 110. So I make a solution box. You got x second only. So you are using linear properties with a square root at the end. So there's two answers. Okay, linear properties is this. So you take out the plus 14 with minus 14. That's going to take you to 96. Negative 2 times x to the second equals 96. Then you divide both sides by the negative 2. That's negative 48. Then find the square root. So x could be positive or negative. You need to poke the I out. Okay. And then I square root 48. That's irrational. Linear properties square root, I've never had you write the irrational decimal. Okay, you label it IRR. Okay. So you put divide by, and then you put the I in the middle. Okay, with the two square roots. Okay, so up on the board, 48, you'd start at 36, doesn't work. 48 divided by again, 25, doesn't work. 16 and 3, okay? Now the square root of 16 is equal to 4, so it's 4i square root of 3. Okay, so 4i square root of 3, and then 4i square root of 3 with a negative. Okay. Last problem, 2x to the second power plus 3x plus 7 equals 0. Okay. Okay, factoring properties now are used. Okay, and equals 0, you have it, and there's three terms. There's two answers. So GCF and the table. GCF's 1. I'm telling you right now, you won't be able to find this. Okay, you will have to use the quadratic formula. So, opposite of b plus or minus d square root b squared minus 4ac, b squared minus 4ac over 2a over 2a. Okay, so you put the opposite of b, it's going to be negative 3. Or no, first off, let's fill this in. So negative 3. B to the second would be 3. 4ac, a is 2, c is 7, and a on the bottom is 2. So you make it plus minus, we have a negative 3 in the front. On the bottom, in the denominator, you need to take 2 times 2. 2 times 2 is 4. Okay, and you plug the inside of that in. So 3 to the second minus 4, 2, 7, negative 47. Now you're gonna have to poke the I out, and you can't. I'm not gonna allow you to put a decimal down there if you poke the I out. Okay, you need to simplify it, just what you're doing here. First, try to see if square root of 47 is irrational. I see that it is. So put the IRR label. Put divided by. Two square roots, multiple square roots with the I in the middle. And we would start with 36, no. 25, no. 16, no. 9, no. 4, no. So it's got to be 1. 1 and 47. Okay, so the 1 becomes 1, just a 1 whole, so I put 1i square root 47. Now remember, we don't do anything after that. We just write negative 3 plus 1i square root 47 over 4, and negative 3 minus 1i square root 47 over 4. Okay, and again, the only way you would even think about changing this is if this -3, 1, and 4 could all be divided by a common factor. The 1 in the radical doesn't count. That stays. That always stays the way it is. But 3, 1, and 4, the GCF's 1, so you wouldn't be able to do anything with that.